This video is going to be reviewing 1-3 and 1-4. Just a quick review. I'm going to be working out the problems on the skills practice worksheets for both lessons, just the odd numbers, so hopefully that'll help you. All right, for number 1, evaluate each expression and name the property used in each step. I'm going to solve it step by step first and then go back and write the property in each step. So here's the first part. Order of operations says I have to do what's inside parentheses, and then I have to fix the exponents. So I'm going to have 7 times 16 divided by 16. The next step, I still have to simplify what's inside parentheses. So that's 7 times 16 divided by 16 is 1. And then lastly, 7 times 1 is 7. So if I went back and wrote the property for each, when I replace a value with something that's equal to that value, it just looks different, that is substitution. And you can look at that, what did I have? That properties worksheet that I had given you guys, that I had posted, I believe it was in this week, the week that we did 1-3. You can look for that and find all the properties on there you need. The sun is like getting darker and it makes it darker on camera. All right, and then going from 16 divided by 16 to 1. This is substitution again. And then when I multiply 7 times 1 and get 7, that's the multiplication identity. And I'm gonna abbreviate identity. Right? Anytime we multiply two numbers together and the original number stays the same, it keeps its identity. That's the multiplication or the multiplicative identity. Okay, number 3. First thing I'm going to do here is multiply 2 times 3. So I've got 4 minus 3, bracket, 7 minus 6, bracket. Next thing I'm going to do is simplify what's inside the brackets. 4 minus 3 times 1. Then I'm going to multiply 4 minus 3, and then I subtract, and I get 1. So if I go back and name each property used, first part, all I did was change 2 times 3 to 6. So that's substitution. Going from this step to this step, I subtracted 7 minus 6 and got 1. Again, substitution. Going from this step to this step, I multiplied 3 times 1 and got 3. That's the multiplication identity or the multiplicative identity. Same thing. And then going from this line to this line, I subtracted, so that is substitution. 1 is equal to 4 minus 3, so I just replaced a value with an equal value. And number 5. I've got 6 plus 9 and then all this stuff in brackets. So first thing I'm going to do is simplify what's inside parentheses in the brackets. 6 plus 9, brackets, 10 minus 2 times 5, brackets. Next, inside the brackets, I'm going to multiply 2 times 5. So 6 plus 9, 10 minus 10. Next, I'm going to simplify. 6 plus 9, 10 minus 10 is 0. And then I'm going to multiply 9 times 0, and I get 0. And then I'm going to add 6 plus 0, and I get 6. So now I can go back and name the properties. So when I replace 2 plus 3 with 5, that is substitution. Feels like we use that one the most, huh? Okay, then going from here to here, I replace 2 times 5 with 10, same thing. Okay, now be careful with this next one. I go from 10 minus 10 to 0, which vaguely kind of rings a bell, right? I did not learn any properties on subtraction, but I did learn a property on addition, which was the additive inverse. And it says when I add opposites, the answer is always 0. I want to show you real quick. I'll just use a little Post-it here so I don't mess anything up. But if I said 10 plus negative 10, that's going to equal 0, right? But if I solve this problem, I can't leave plus minus together like this. So I'm going to replace this with 10 minus 10, right? Replace these two signs touching, they're different, so I replace them with a minus sign. Same thing as if you solve this problem right here. This is the same thing as saying 10 plus negative 10. So when you have the same number and you're subtracting and the answer is 0, that's the exact same thing as adding a negative number, right? So here we're adding opposites and the answer is 0. That's our additive inverse. And you can go back and review that if you need to. Let me scoot this over. Okay, next, going from here to here, 9 times 0 is 0. That's the multiplication property of 0. What am I doing? Prop of 0. Multiplication property of 0. That was bad writing there. And then lastly, 6 plus 0 equals 6. I'm adding. And my number 6 here keeps its identity. It stays the same. So this is an additive identity. All right, you guys should be familiar with these. If you're not, go back and review those properties here. Multiplication property of 0 says whenever you multiply anything times 0, the answer is always 0. So 9 times 0 equals 0. Multiplication property of 0, and then 6 plus 0 equals 6. That's the additive identity. 7. Here we're going to start solving first. So I don't have any signs other than plus signs, right? So I learned two properties and we barely touched on them, but they are in your notes and they were covered on the video, the lesson video for 1-3. The commutative property and the associative property, okay? And they apply whenever all you're doing in a problem is adding or all you're doing is multiplying. Here we're adding, so we're probably going to be using one of those two properties, the associative or the commutative. So here, if I look at these numbers, like mental math, I'm going to group them kind of different. So I'm going to move numbers around. I can't group them with parentheses because the ones I want to add together aren't next to each other. So I'm going to move the 14 next to the 16, and then I'm going to move the 8 next to the 12. Okay, and then after that, I'm going to group them, right? I'm going to group 16 plus 14 plus 8 plus 12. And then when I do that, 16 and 14 is 30, and 8 plus 12 is 20. That's easy mental math, right? Because 6 and 4 is 10, so 16 and 14 is 30. 8 and 2 is 10, so 8 and 12 is 20. And then I know that simplifies to 50. So when you kind of use mental math and you move stuff around and group it, it makes it easier. Okay, so the property that we learned that says that we can move numbers around and that doesn't change anything, the value doesn't change of the problem, we're just moving stuff around, that's the commutative property. Like think about how you get to school. It's how you arrive there, how you move to school, your transportation, right? It's talking about moving. Your commute. So the commutative property says we can move numbers around when we're adding. The associative property is a grouping property, and it says we can group stuff however we want when we're adding. We can add them in whatever order we want to. It doesn't matter. So I'm going to group, my dog's barking, I'm going to group 16 and 14 and 8 and 12. I didn't just add them in order from left to right. I kind of grouped them. So that's the associative property. The associative property, so we could have added 14 and 8 first, and then added 16 and then added 12. We could have done that. Doesn't matter how we group. In this case, we grouped like we did because it made mental math easier. It was easier to add 8 and 12 than add it somewhere else. All right, and then we replaced this line with this line. So we replaced 16 plus 14 with 30, and 8 plus 12 is 20, so that's just substitution. And then we replaced 30 plus, we replaced 30 plus 20 with 50, again, substitution. All right, and lastly, number 9, this is all multiplication, so we're probably going to be using the commutative or the associative property. So here, does it make sense to move anything around? Well, don't know, if I multiplied, that's 15, that's 12, that's 20 and 9. I'll probably move it around so that 5 and 4 go together. 5 times 4 times 3 times 3. There is not one right answer to this problem, so you didn't have to do that. You could have just grouped or just used substitution the entire time if you just wanted to solve it in order. That would have been fine as well. But you have to list it one step at a time. If all you did was first multiply 5 times 3 and then multiply it by 4 and then times 3, you'd have to list that out in 3 different steps, right? You can't multiply more than one thing in one step. Each operation gets its own step. So here I move stuff around. So now I'm going to have, if I group, well, I'll just show I group 5 times 4 together times 3 together. Then that's going to give me 20 times 9. And I know 2 times 9 is 180, or sorry, 18. So 20 times 9 is going to be 180. Okay, so here going from the top to the bottom, I moved numbers around. So that was the commutative property. And then I grouped numbers, how I wanted to multiply them out first. So when you add parentheses there to group them, that's the associative property. Think about like your group at school is made up of the people you associate with, right? The people you associate with, that's your group. That's your little group of friends. So the associative property is the grouping property. Then in the next line, I replaced 5 times 4 with 20 and 3 times 3 with 9. Yes, I just got through saying that and I didn't do it. I should have done it in 2 different steps, right? I should have first done 20 times 3 times 3 and then 20 times 9. I didn't do it. But either way, those 2 steps should have been substitution. And then going from 20 times 9 to 180, again, that's substitution. So I should have added one more line in here, like 20 times 3 times 3, which would have been substitution. And I didn't do it, but that's okay. If you had just done, I'll even do it below here. If you had just done, it says 5 times 3 times 4 times 3. If I'd first done 5 times 3 and said that was 15, and then still had times 4 times 3, and then in the next line, 15 times 4 is 60, and then in the next line, that's 180, I could have done that, and the whole entire way, it just would have been substitution. That would have worked as well. These little commutative and associative property problems are a little ambiguous. And you're not going to see I just wrote substitution. Substitution. All right, you know what it's supposed to be. Substitution. But they just give you, just so you see practice, whenever you see everything being multiplied or everything being added, just know that it's probably going to be using commutative and associative. Those are the only 2 properties that apply to all addition and all multiplication. Okay, and then that was 1-3, so let's do 1-4 really quick. That's a little easier, the distributive property. For distributive property here, I'm just going to do the odd problems again. So use the distributive property to rewrite each expression, then evaluate. So if I yes, you could add 3 and 5 and get 8, but that's not what they said to do. They said use distributive. So I need to multiply the 4 times the 3 and multiply the 4 times the 5. So I would get 4 times 3 plus, because I have a plus sign here, 4 times 5. 4 times 3 is 12, 4 times 5 is 20, and 12 and 20 is 32. Number 3, same kind of thing. I'm going to multiply 5 times 7 and 5 times 4. So I'm going to have 5 times 7, bring down my minus sign, 5 times 4. 5 times 7 is 35. 5 times 4 is 20. 35 minus 20 is 15. Then I have 5 times 89. And what are we supposed to do here, right? Nothing is in parentheses. What they want you to do is separate 89 into 80 plus 9. So you're supposed to be doing 5 times 80 plus 9. Because mental math, it's easier to multiply 5 times 80. That's 400, because 5 times 8 is 40. Just put a 0 on the end. And 5 times 9 is 45. And then in your head, you can add 400 plus 45 and get 445. That's a lot easier to do in your head than try and do this in your head, right? So now, like I said, we can multiply, and we'll get 5 times 80 plus 5 times 9, 400 plus 45, which is 445. Okay, same thing here. We want to separate 104 into 100 plus 4. Because that's equal to 104, but it's going to be easier mental math for us. Okay, so I'm going to have 15 times 100 plus 15 times 4. 15 times 100 is 1500. 15 times 4 is 60. So we get 1560. That's all they're looking for there. All right, 9 and 10, use distributive property to rewrite each expression. Then simplify. So multiply here. So I'm going to get 2 times a plus 2 times 7, which will be 2a plus 14. And the next one, number 11, 3 times m plus 3 times n. Your number in the middle here should match the number in the middle here unless one of these terms is negative or the term outside. And once you start mixing negative signs in there, you might have to switch some symbols around. Okay, and then lastly, the bottom here, simplify each expression. If not possible, write simplified. 2x plus 8x, we can simplify to 10x. 2x squared plus 6x squared, these are like terms, so we can simplify that to 8x squared. 3y squared minus 2y, these are not like terms. There's no equal sign other than the one I just put there, so we can't solve for a variable, so this is simplified. And then number 19, I can distribute. Right, 4 times 2b minus 4 times b. That's 8b minus 4b, which is 4b. That's the final answer. And then lastly, write an algebraic expression for each verbal and then simplify, indicating the properties used. Okay. So we're going to start off with an equation, simplify it step by step, and say which properties we used for each. The product of 9 and t squared, product of, and then we look for and. So I'm multiplying that guy with that guy. So 9t squared increased by the sum of, so increased by means plus. The sum of means plus, and I'm gonna see the word and that's gonna tell me what two things I'm adding. The square of t squared, and 2. Okay, so I have 9t squared increased by plus the sum of. When you see the sum of, that shows that I'm gonna have to figure out what these things add up to first. So I do that inside parentheses, and then whatever I get, that's what's being added to 9t squared. So I got to do this last part in parentheses. T squared and 2. T squared plus 2. Just like that. All right, and then if we simplify, we're just going to remove parentheses and then 10t squared plus 2, and we're done. So this entire time was just substitution, I guess. Okay, next one, last one for these notes. Yay, 3 times the sum of r and d squared. Okay, so 3 times the sum of, so I'm adding and I look for the and sign, r and d squared, minus 2 times the sum of r and d squared, right? That's a whole lot of stuff going on. So we're just going to do it in order from left to right. 3 times the sum of, so that's going to show that I have to add these things together before I multiply it by 3. So I have to use parentheses. R and d squared, r plus d squared. So 3 times the sum of r and d squared minus 2 times the sum of, so I'm going to have to use parentheses again and add this stuff at the end inside parentheses before I can multiply it by 2, r plus d squared. I went a different direction with this, and when I started solving, I realized I went backwards, so starting over here on a different sheet of paper. So I got to this point. The next step now, I'm just going to distribute. You notice that both of these are being multiplied by the same term, the same things in parentheses. I was trying to factor that out. That's not what they're looking for. So now I'm just going to multiply. 3 times r is 3r. Bring over my plus sign. 3 times d squared is d squared. Now I've got this minus sign. Now this minus sign actually stays with this 2. This is a negative 2, and it gets multiplied by each term here. Whenever you have a minus sign here, it stays with that number in front of parentheses, and you multiply everything. That will affect your answer if you don't keep that minus sign with the 2. So negative 2 times r is negative 2r. Bring down our plus sign. Negative 2 times d squared is negative 2d squared, right? So now I can simplify that. 3r plus d minus 2r. And then I have plus minus, which just simplifies to a minus 2d squared. And now I'm just going to combine my like terms. 3r minus 2r is just r. D minus 2d squared is just negative 1d squared. And this would be our answer. I'm not going to go through and write all the properties because it's just substitution. That's all we're doing. We did distributive property from here to here, and then from here to here and here to here. It's just substitution. All right, if you have questions, let me know. Good luck on your assignment.